G'day, my name's Barlett and I'm here with Nate DeCray.
Hey.
We're at the FPV time trials for the championships coming up in July.
Yeah, we're practicing.
And as you can hear, there's lots of activity around us. The field's looking pretty cool. And I just wanted to quickly show you this setup that I put together yesterday. Nate and I have been talking about frequency management and coordination at these events, which can be sometimes a bit of a problem. Can you explain how it's a bit of a challenge?
Sure, yeah, absolutely. So we use a lot of different frequencies at FPV events. We've got control frequencies, often in 2.4 gigahertz range. We've got video transmissions in 5.8 gigahertz, sometimes in 2.4, and even occasionally down to 1.3. So we use a lot of different spectrum to do that, and there's a lot of different transmitters. Almost every aircraft has a transmitter on it and can potentially be a jammer to other aircraft. So it's very interesting for us to monitor the spectrum usage and know what's going on.
So Nate and I were chatting, and we would think it'd be really cool to be able to monitor the radio spectrum and see which channels are in use, and therefore be able to allocate free ones to other competitors that want to get in the game. So yesterday I thought, well, I'll have a quick stab and see how far I can get, and I put together a little bit of a prototype here. I've got my Macintosh running GNU radio, and that's hooked up via a Thunderbolt connection to this Thunderbolt to PCIe converter box, and that enables me to have a 10 gigabit network interface there, which is hooked up to this USRP X310. I'm plugged into the 10 gig port there, and in the X310 I've got the new UBX daughter board, and this is the UBX 160, so you can get a total of 160 megahertz worth of usable bandwidth out of it. But the tweak that I made here is actually that usually you can stream at, for example, 200 megasamples per second or 100 megasamples per second. Here I'm streaming at 100 megasamples per second, so at any one time you're looking at 100 megahertz worth of bandwidth. But I just prototyped a little GNU radio block yesterday, and that just sits in here. It's called the hopper block, and that sits downstream of the USERP. And what it does is it actually streams from the USERP and then tells it to hop frequency very, very quickly, and then stitches the FFTs together into these very, very wideband waterfalls. So on the bottom one, it might be a little difficult to see because of the glare, but this is the 2.4 gig band, and you can see a huge amount of activity there, which is everybody's remote control sending commands to their drones. And then the top waterfall is actually the 5 gigahertz band, where we're looking for activity from the FPV video downlinks. And if you see here on the very left hand side, somebody's actually transmitting their video from somewhere, and you can see that activity on the waterfall. It's a little bit quiet now that people have sort of stopped flying as much as they were before. But how does this kind of fit in with your idea of spectrum management, Nate?
Absolutely. This is definitely a tool that would be very useful for us. We're going to have 100 to 200 different pilots, and managing all of them and being able to see what's going on. And not only that, to be able to monitor the impact of other video transmitters that might come in for media and like that. It's an excellent tool. Very good. Very excited.
Thumbs up then.
Definitely. Thanks, Valen.
Yeah, so these waterfalls are actually at the moment stitched together, and you get a composite of about 300 megahertz. Last night I had 3 by 4, so it was actually 1.2 gigahertz worth of stitched bandwidth. And actually somebody else has turned on their FPV transmitter on this other frequency there on the side. So yeah, with a bit more refinement, it should be good. Thanks for watching. See you at the drone championships.